Notice the directions say identify the critical points and determine local extreme values. I know some of your homework last night, if you looked it up, they did do both absolute and local. We didn't really talk about that. But definitely we can use our points to help us figure out local max and mins, but the calculator will kind of verify that for us, and that's where we're going to go. You should not be looking at your calculator at the beginning of these problems. You should be looking at them towards the end, verifying that your numbers work out the same way. What's so exciting about this problem? Product rule. Not really chain rule, just product rule. But the derivative of x is just 1, right? And this one doesn't have a power out here, so it's not a chain rule either. It's just product rule. So if I do my derivative, product rule, I'm going to take the derivative of the first. So I'm going to get 2/3 times x to the negative 1/3. Leave the second one alone. That's just the power rule. Chain rules when you have to multiply by the derivative of the inside. There's nothing on the inside there. Just saying. Plus x to the 2/3. Sorry, I like to leave my first one alone. And then multiply by the derivative of the second, which would just be 2x.
Remember last chapter, we had to do the logarithmic differentiation. We have like well, we have to do that here sometimes. If we have an x.
If you ever have an x as a base and an x as a thing, you would. It doesn't really matter. At least not right now. What else do we have here? I'm going to put this as a fraction. So this will be on top and this will be on top, right? So that would be like 2 times x squared minus 4. But the 3 is in the bottom of the fraction, and this negative exponent means I could put that in the bottom of the fraction. You agree with me on that? What happens when I take x to the 2/3 times x? Right, this is like 1, but if we're adding these, because that's what you do when you multiply, this would be the same as x to the 3/3. Do you agree with that? So 2/3 and 3/3 is 5/3. Oh my goodness, look at us doing fractions. If I'm going to solve this equal to 0, having one fraction is way better than having a fraction and something added to it. Because having one fraction equal to 0, you can just kind of forget about the denominator and set the top equal to 0. Which means I really think we should get a common denominator here. Which means maybe I should have left this as a... Remember that this is x to the 1/3, right? Keep our exponents as factor. And it's in the bottom. If I'm getting a common denominator, do you agree my common denominator is 3x to the 1/3? Because it's in the bottom, I'm not moving it up. Yes? So right now this is over 1. If I wanted to get a common denominator, I need to multiply by 3x to the 1/3 on the top and the bottom. It works out so nice on the top there. Look at those fractions. Over here I still have 2 times x squared minus 4. But if I put this all as one big fraction, what do I get on the top up here? 6. And x to the 5/3 times x to the 1/3, I'm adding those, and I get x to the 6/3, which is x squared. Which makes it so much nicer to solve it. And my bottom is still, you can write it as x to the 1/3, I don't care. Or you can write it as the cube root, whatever you want to do. I'll leave it as 1/3. With me on that? Again, that algebra part is very, very important, knowing how to get a common denominator. So now if I set this equal to 0, do you agree I'm just setting the top equal to 0? Yeah, I will, when I'm setting it equal to 0. Because I have to actually solve it now. So I would get 2x squared minus 8 plus 6x squared, which means I can work that out. I'm just waiting. Because really, unlike what we've been doing, the derivative is just there to solve it. And so I'm just going to wait to solve it when I set it equal to 0. So I get 8x squared minus 8. And you can do some lovely algebra there, and it actually isn't so bad at all, right? I can add 8. And I can divide by 8. And I get what for x? X equals plus or minus 1. What else do I have to do? Figure out where it's undefined. If you have an x in the bottom of your fraction, it's going to be undefined somewhere probably. And for this one, where's it going to be undefined? 0. So I'm also going to say x equals 0, and remember that's because that's where it's undefined. Wait, what was that? That was my undefined part. Basically it's like you set the bottom equal to 0, but since it's just a multiplication problem with x, then I know it has to be 0. Because where the top equals 0, yes. They didn't give me a domain there, which means it's over its entire domain, which means that's not a closed domain up there. There's actually nothing up here. Cube root, I can actually even have negative numbers. This is going to not be a pretty graph, but it's nothing's restricted, and so everything's allowed, which means I'm just going to be checking these numbers. So I'm going to check x equals 0, x equals 1, and x equals negative 1. And again, I want you to start thinking about doing these without a calculator, because when you take the AP test, you're going to have to be dealing with these fractional exponents. And dealing with 0 and 1 isn't so bad plugging these in. But I would get y equals 0 to the 2/3 is just 0, so it really doesn't matter what's over here. We would just get y equals 0. You agree with me on that? For 1 and negative 1, when you plug 1 in here, what is this the same as doing? Yeah, it's like the cube root of x squared. So I'm going to square it and then take the cube root of it. When I square 1, I'm just going to get 1. When I take the cube root of 1, I'm just going to get 1. So I end up with 1 times 1 minus 4 is negative 3. So I think I get negative 3 there. What happens with negative 1? Does it give me the same answer? Because both of these are squared, right? So when I square negative 1 and I square negative 1 here, it's going to be the same thing. So I think that I also get y equals negative 3. Here's what I want to caution you about today. This is not a closed domain, which means this is definitely bigger than this, but you got to make sure you know whether it's an absolute maximum minimum or a relative max or min. And today, because we don't have the other way of doing it, we're going to look at our graph to kind of determine this, to see what's happening. Okay? So graph this. X to the 2/3 times x squared minus 4. And remember that when you hit your caret button, you have to make sure that you want it to be 2/3 up there. If you just write x caret 2 divided by 3, your calculator is only going to do x squared, and and then divide the whole thing by 3. So you have to put parentheses around that, or it will not give you the right graph. So make sure that you are practicing doing this, which is why I want you to bring your calculators. What? Sarah, seriously. Oh my goodness.
There you go.
I know. I have to do all this stupid stuff.
No, it's like really slow because they're narrow.
It's fine. That's why I'm an expert smartboard person. It's really not that big a deal. Just get in the general area. We found, what do we have? -1, -3. These are both of these points. Are those absolute minimums or just relative minimums? That's the lowest. So we can say for sure that there is minimums. You don't have to put the word absolute there. And you can just give the points if you want. There's a minimum at -1, 3 and 1, 3. Both of them are the lowest point. And what was our other point we found? No, I don't think it's undefined. We could zoom in there. It's just kind of a point there, I think. It's undefined in the derivative. Why? Because it's a point there, but it really is defined there. Is that the highest point on the graph? Is that the highest point in that general area? So you need to make sure you say there is a relative max at 0, 0. Caitlin.
I thought the -1, -3, -1.
Yes, you're right. It's both -3, right? Sorry. Again, notice I didn't graph it till the very end. On your homework and on quizzes, up until we learn the calculus part of this, where you're using your calculator, if you just have the answer, like you graph it and you look at the answer, but you don't have the work to go with it, you're not going to get points for that. So make sure you're saving the graphing part till the end. How about this one? Y equals 3 minus x when x is less than 0, and y equals 3 plus 2x minus x squared when x is greater than or equal to 0. The big thing about piecewise functions is it's two different graphs joined together. So one thing you got to make sure is that they meet up at a point. That'd be a nice thing to know, and that point could be a maximum in itself. But the other thing about piecewise functions is you got to look at both sections. You got to look at the derivative of this one and say, does this one have any critical points? And you got to look at the derivative of this side and say, does this one have any critical points? So let's do the critical point part first, and then we'll look at the graph, like we did on the last one. So I'm just going to kind of go with the top one first, and I'm just going to say this is y equals 3 minus x. Notice it's only for x is less than 0. So if I got a critical point bigger than 0, it's not on my graph, so that I wouldn't include it. What would the derivative of this be? 1. Where does that equal 0? Where is that undefined?
Anywhere less
What?
than 0.
What does this look like when we graph it? It's just a line, a linear line. Does a linear line have any max or mins? No, except for if it was a closed domain, it doesn't have anything. It's just a straight line. It doesn't have any highs or lows. So it makes sense that this has no critical points. But I also have to look at the second one. Y equals 3 plus 2x minus x squared when x is greater than or equal to 0. I'm going to find the derivative of it and also look to see where it's 0 or undefined. And again, look at these nice derivatives. Remember back in the day when this was hard derivatives? See, someday you're going to look back at the crazy chain rule and you're going to be like, man, what when I didn't understand the channel? Remember when I did the product for all of my S?
Are you looking at your phone?
You're so nice.
I did it too. Well, I don't like it.
At least
Yeah, it's
like
23.
Yeah, if I put one in just 23 on the first side. Remember that? Someday you'll look back and you'll be like, oh, this is so easy now. X equals 1, yes, we agree with that? Is this undefined anywhere? So what shape is this going to be? A parabola. Parabola's not undefined. And so again, think about if your answer makes sense. Here's the other thing. You got to make sure sometimes the point where they meet up could be a max or a min, either absolute or local. So you really do have to look at the graph of these as we're doing this. Let's just graph this then. Before we go any further here.
Wait, so it's one a critical point?
It is a critical point.
The next?
I don't know. That's why we have to look at the graph. My dividing point is 0, which is really nice because that's just my y-axis. So half of my graph should be to the left of the y-axis, and half of my graph should be to the right of the y-axis. 3 minus x means I have a y-intercept of 3, yes? And that would be an open circle. And a slope of -1. Since I'm graphing to the left here, I'm going to go up 1, back 1. Up 1, back 1. And it would look something like that. Do you agree with that? Good old piecewise. 3 plus 2x minus x squared. It's going to be a parabola. I say really we could just pick some points here. We could factor this and try to find the x-intercepts, but I'm just going to pick a few points to get the general shape. What would be the best point to start with? 0, because that's where my graph is starting. And if I plug 0 in there, I'm going to get 3, yes? And this one is included, so look what they meet up so nicely there. If I put 1 in there, I'm going to get 3 plus 2, which is 5, minus 1, which is 4. Do you agree with that? Is this parabola opening up or opening down? How do you know? Without randomly guessing. The x squared tells you. The negative in front of x squared tells me it's opening down. So probably this should go at some point. I'm going to pick another point and see if I can figure out if it's going down or not. If I plug 2 in there, I get 3 plus 4 minus 4, which equals 3 again, which means I've just found my vertex. So I'm just going to wing it from here.
I definitely graphed on my
Your
calculator.
mathematician doesn't wing things.
Good mathematician can make
Oh,
a
never mind.
decent sketch of a graph. So we got a critical point of x equals 1. We plug that back in. We're going to plug it into the top or the bottom? The bottom, and we actually already did it, right? Over there on my XY chart, what did I get when I plugged 1 in there? Looking at my graph, 1, 4, is that a max, a min, a local max, a local min? It's definitely a high point on my graph, but it's not the highest point because this keeps going up forever. So I could say that there is a local max at the point 1, 4. Is there any other relative extrema on here? Because they meet up and that's a closed circle, it is an included point. And although it's kind of a sharp curve, wouldn't be good to take the derivative of it. It is a low point on that graph. Both of these are higher around it. So it's not the lowest point because this goes down forever, but we can say that we know there's a local minimum at 0, 3. And the only way we know that is by graphing it. And so when you see piecewise ones on your homework today, I really want you sketching the graph because you can find the critical points But you got to figure out that there's another one on there where they meet up. That's not so bad, right? Maybe the first one was kind of bad. It's really a lot of algebra, and I really encourage you to be trying these problems, not just copying out the back of the book or from your graphing calculator. That's why we're spending another extra day on this before we move on. So here's your homework. 35, 45 odd, 48, 49. Again, giving you the odd answers. You shouldn't even really need the odd answers because you could graph all of these on your calculator and get the answers as well. But I'm looking for the work to go with those, the calculus work to go with those. Try to remember to take your graphing calculator home with you this weekend because you are going to be using your calculator to check whether they're max and mins. And also really try to remember to bring them on Monday. Maybe instead of throwing something at you, I'll try some positive reinforcement, and everyone that has their calculator with them on Monday may get a treat.
Like, really a treat or not extra credit?
Yeah. Not extra credit, like food.
I love food.
Yeah.
And if you don't, then we're all going to eat in front of you and laugh at you for eating your graphing calculator. I've had this calculator since day one.
Why do you
This
do that?
is why I don't bring it to.
I bring my graphing calculator every single day. It weighs up my. I
Every class. You should learn to bring it with you all the time.
Every
Because
class. I have this.
this is what we should be using all the time. We should not be using our scientific calculators. We should always be using this. Comfortable with them.
I get my English test back and I look this up.
Yeah, everyone's like, hey, can I use your calculator? It's like, no, you can't use my calculator. It's graphic. They're like, well, it's fancy. It's like, yeah, it's fancy. I think I might have recorded that I was going to hit you with something. That's not good.